Okay, we're going to go through the crank assembly and do the higher level of tolerancing. I already have the sheet open. So one of the things we want to do is go through the stack up of tolerances, and if I add a layer, and let's go with a new, I can just call this a no print or a table. Something along those lines, but I would want to be able to um, go back through and do this stack up of tolerances, but not have it go out on the print. It's more for documentation purposes. So if I do a general table, let's go 4 by 3. Okay, we'll place that. Then we're going to, if you look at our fits of a running fit, a transitional fit, press fits, and then light broken down into light press and heavy press. We're going to be talking about the hole basis and the shaft basis of the geometry. So if I go this direction, hole minus, and I'm going to go ahead and shrink those up a little bit so it's a little more manageable. And then shaft minus, we should be able to see. And I've tried this both ways with the plus and minus, but just kind of see whichever one works better for you. All right, so our number that we're looking for is the bearing is the purchase part. So in this case, the hole in this part is driven by the OD or the shaft of the bearing, and it is listed as, let's pull in the website. So our R12, I did go back and do a price comparison of the shielded permanently to the open, and $9 versus $25, but still not as good as the the bushings for what we're doing. All right, so the OD tolerance minus 5 thousandths plus nothing. So we should be on the high side, 1.625, and then 1.6245. And probably need to make these columns a little bit bigger. All right, so if we do the double click, kind of like Excel, where we can modify those. All right, so then and I already reversed those. So we want to go the other way. 1.625 and the minus 1.6245. All right, so those are at least proven out. Then the hole, if we go with our tolerance, 1 point on the high side of our number, 6245, and 1.624 on the minus. Got to remember to put those zeros in there. Then our best number would be 1,000th and 0. All right, so if we had have those values, we want to ensure that this goes from a translational fit to a light press. And with transitional fits, they can either be a light slip or a light press. And we don't want to crush this this bearing putting it in, but we don't want it to spin. It's the shaft and the interface between the shaft and the inner race that we want to have apply that geometry. All right, so we went with the plus 5/10, and so the size of the bearing, the 1.624 with the plus 5, and then the shaft size. All right, so I'm going to copy this over. The other thing is I don't do drawings um, for purchase parts. We have that documentation, or in our bill of materials, that geometry. So um, I'm going to be able to reference back, and then ultimately we're going to get these purchase parts in and see where they fall out. So I looked at an undersized rotary shaft for this material. Still not fond of the spline end. I think there's better ways to do that or easier to machine. But this particular shaft is minus a half thousandth to minus 3/10 of a thousandth. So on the shaft side, we're going to be 0.749 to 0.7495 as our tolerance zone. And then the bearing, when we come back to the inner race, 750 plus nothing minus 3/10. So 7500 to a minus of 0.74, and double check my number, 497. All right, so our best case goes 0 to 0.005. All right, so from a light slip, I don't think we're going to get a slip unless we are just at the low ends of those tolerances, which if we're at the mean values will be pretty close. But that's going to put this back into the precision shaft of we almost need to do a bilateral tolerance, or call out the part number again. So if I was to grab this part number and place a note, let's see, that one's on the DIMS layer. And I don't think I modified. Okay, there, it jumped over to the no print. So then this becomes a purchase part, but it's modified, so we do need a dimension for it. And instead of bilateral, I'm going to do a symmetric that goes back to this geometry. So on the shaft size, we had, let's see, I needed a limit. We want a plus, and I think I can do a minus 0.003, and then a minus 0.05. And if I didn't go too far on those, we do need to change the precision then, so that we actually see that fourth decimal place. That's going to give us that value, and because it's a purchase part, we're not really going to machine it. I might polish it a little bit. And I don't know if it would need that, but it would be an inspection dimension because we'd want to verify that that geometry. All right, so again, with those prints, if I go into the or actually the no print, it's not going to show up on the print, but it leaves something that I can check. Now, it did show up on that one. So why did it show up on that one? Okay. Maybe. Okay, it's there's a little glitch going on there. Anyway, let's move on to the GD&T. I don't want to get into the kind of the same with the fits, as there's certainly a lot more doing the stack up of tolerances and doing the best manufacturing processes. After we've run a few of these, we could see what the tool wear is, how much taper we're getting in this geometry. It's going to be the same with the GD&T. What is going to be critical and really useful to us, but until we get to that point, we have to figure it out. So find a color that is close. And should be okay to print and to put that geometry in. All right, so just going through the process without going too far into the GD&T is we need some datum features to start with. And it jumped to my dimensions, so no, I do not want that one. I want it to make sure that it's getting attached. And B can be the front. Okay, that's kind of strange, but we'll take it. All right, so that applies the datum. Since these are going to be driven by our geometry, let's see, I think it's just going to be that one. We're going to switch it over to a basic dimension, and it's going to be centerline. So, really that centerline, I would have to look at the standard and refresh my my memory on the best way to show that geometry. But the 2.5 from datum A is a basic dimension, and the positional tolerance will control its tolerance. So we want to add then a geometric tolerance of flatness. So I'll make sure that that is not getting too far in the way. All right, so flatness, let's put 2 thousandths on it. And done. Okay, and then we'll kind of move that out and away a little bit, clean it up. And then the next geometric tolerance for our stack up, if I need a positional tolerance, and again, there's more math involved in this than just applying these. So datum A, A to B, no, it's not a compound, so add new, and we'll go B, and done. So we can just say 10 thousandths in relationship to A and B controls some of our basic concerns of the geometry. So this one's already inspection dimension. Something like this, we would look at maybe putting in cylindricity and controlling that that shape. But it's it's purchase part, but we do want to maybe inspect it. So we'll go with a geometric tolerance, apply. And we're going to go cylindrical, and we want it, actually, what did they give us on our tolerance here? Straightness. All right, so that's not really going to be, we'd have to translate that, figure out what we need, but realistically, if we were within the 10 thousandths, that's probably going to be fine. So 10 thousandths of cylindricity over the length. A little bit difficult to read on that one, so I want to, let's see, there it is, add a jog point, and then we can kind of move that around and clean up the drawing a little bit. All right, so if there's other GD&T you want to put in, we look at this and we have the tolerance, which was kind of the press fit between actually, it was this end. So we have that number. We would almost need to do, well, we pretty much need to do the same thing for this as the stack ups. especially since it's not constrained or being retained. So the 750, yeah, we'd want to see about pressing. But the other part of that too is with this geometry and the keyway and our keyway defaults, that when we go to press that together, lining those up, um, making sure that that interface goes together smoothly, but also doesn't come apart. So that's going to come up in the design review. There's better ways to address those items. But for our assignment, this completes out what we need to do just to add some of those um, general tolerances and be able to interact with the geometric tolerances.